Okay, Bismillahirrahmanirrahim. Assalamualaikum and hi to all gentlemen and ladies. So this is a project for the subject computer networking with the course code BIC21303. I'm Arif and the project title is Small Office, Home Office or SOHO. So this is a network design with the gas network. So this is the SOHO network design or the part one of the project, this subject. So we go to the project scope. So a small business network is to be designed for an organization. The organization has occasional guest user, maximum 12 visitors. So which means it will have for the guest user 12 and device, but we can represent, I think, not only PC, we can also use laptop for the guest user in visiting the business premise. So there are a total of 60 users in the organization, which means the user 60 we can represent as 10 PC inside the organization, which means one PC will represent 10 PC. And FTP server for internal file sharing is required for all the 60 users. So we will have the server farm as usual. When we have the server farm, we can implement the FTP server, DNS server, DHCP server, email server, but I think it's only enough for 3. The common server, which is the FTP server, DHCP server, and DNS server. So for the SOHO, actually we don't need to implement the multi-layer switch, because my lecturer said that SOHO doesn't need that device, but it depends on your lecturer, because when we need to make the network design become hierarchical, we just need to implement the multi-layer switch and connect to the router. So next we jump to the network requirement. So we will use router 4331 with the quantity 1 on the center of the network. Next, the switch we just use 2960 quantity 5, because logically and in real life one switch can suit 24 port. So for the 60, I think three three switch is three switches is the best fit. And for the server pump, which have one server, and for the gas network, gas user will have one server and one switch also. So after that, to connect between the end device to the switch and switch to the router, we can use copper straight through cable Cat6. Okay, and next to on the interface on the router, we just add the GLCTE quantity 2, and after that to connect between the switches, just use the crossover cable. So next, go to the network planning. So the task is Transfer packet of data among networks is assigned to router. That's the function lah. And allows all other devices on the same network to communicate and share file, which is switch role. And after that, connect device to wire network copper straight cable, and to access, hold, and transfer all file and data from the other computer over the computer network is a server. And to enable gigabit Ethernet connectivity over fiber optic or copper cable in an environment with extreme temperature condition is GLCTE. And the last one is facilitate this direct connection between the switches is copper crossover cable. So next, when we design the network, we can or we mandatory or to create a IP network design table, or other name is called as IP subnetting. So for my group is be given the IP 199.10.10.0. So from this project, there are 3 subnet. I'm divided into 3 subnet. So the first subnet will be assigned to the user, which have 60 hosts or end device. And after that, the second subnet is for guest user. There are 12 user. And the last one, third subnet, is for the server. So from this, after we can identify the number hosts needed, we can calculate the number hosts supported. So from this, the best fit subnet mask is 26 network bit, because 32 minus 26 is become 6, and to the power of 6 is 64, and minus 2, why minus 2? Because it reserved for network address and broadcast address of the subnet. So from this subnet address, this is the network address and this is the broadcast address. So from this minus 2, 64 minus 2 is become 62, and 62 until the usable host is 199.10.10.1 until 199.10.10.62, and the gateway address is 199.10.10.1, which I'm assigned to the router. So router is become the default gateway of user subnet. So next we jump into the guest user subnet. So I just use the best fit is network bit 28, because it will fit the suit the host supported is 14, and only 12 is needed, and it's a best fit for 28 network bit. And it's for guest user. After that, I'm just go to the server farm. So there are 3 servers, so which means I can just use the network bit 29, because it will support 6 usable hosts, and they are the best fit for this subnet. So next we go to the physical network design, where we need to go or execute inside the packet tracer. So but for the physical network design, Actually, we need to make the logical network design first, and after that we can just edit or arrange the physical network design. So let's go to the packet tracer. So let's start with the router. So I have used 433 router. Just rename as main router 1. So after that, there are 5 switches, right? 5 switches. Copy, paste. Oh. So this is for the user network. One switch is only for the guest user, and this is for the server farm switch user. I just rename as switch user 1. And this will be switch user 2. This will be switch user 3. And this one is switch guest user. Because it's just need to, the capacity of the guest user is only maximum 12 user, so it just need one switch. And for the server farm switch server, just need to fit or suit 3 server only. So there are many unused port inside the server. So from this, just to insert the end device, which is the PC. So for the user, one PC is represent as 10. So to become the 60, you just need 6 PC for this part. Now there are 6 PC here, and I need to arrange and rename this part first. PCB PCC CD CE F A B C D E F. Right, just put the switch between the end device, this group. I try to make it as a parallel switch. For the guest network, just need, it's represent one device represent as 6 user. Yes, to portray as the guest, just use your top and the PC. So now I just rename this part. So for the server, just click 3 server. So we start with the SCP server. FTP server for file sharing, and DNS server. So now let's connect with the connection between the device inside this network. This SOHO, small office, home office. That's a type of the network. So thread copper, thread copper thread through cable. Oh, I see. I need to add-ons. Ons, but I need to off this pipe, this router first, and add-ons this. To right, extend the interface. It's on back, switch on back the router. So now just connect with the copper thread through cable. Oh, see, it's wrong. Let's connect with the end device to the intermediary device first. Disconnect all the cable between the device. So as we can see, the is up, all the green is mean up the network, the networking between them, and red light, which mean the network is, and there is no routing in this traffic there is no traffic routing inside this. Because this is a server, we need to configure the router first. Sorry, my mistake. We need to configure the router first to make it this cable or this area have the traffic routing road. So this is the logical so I need to screenshot first. Right. Never mind, we go to the physical first. Let's arrange. Alright, this is the physical. So let's take it's loading sniping tool for the purpose of screenshot for the physical network diagram. Actually is the inside main wiring closet. So I just screenshot this. It's the physical network design. So the next is logical network design. Just go to the packet tracer and click logical. So actually we need to insert all the IP and list the IP. So just make it the VLSM here to draw the rectangle here to make the other pupil acknowledge that this is the other subnet between this network. So I just choose the field color. I see my mistake here. The user. This is the guest user, and this is the server. Also, actually we can place all the node, the description or the IP of all device and the default gateway IP. Also for the router, main router. So let's assign all the IP here to make the process IP assignment becomes easier or simple, because we can refer to the node here. Let's start with router first. Next, the switches of the user network. So this is for the guest user network. This will be the switch of guest user will be the default gateway for the guest user network. Actually, it's good for us to place a note of the interface name to reduce the human error. Reduce the percentage of human error will occur in here, and just list down all the interface. And also it's a good thing when we configure the router to activate the interface, and also it will reduce our time when configure the router. So this is for the server. So for now, this is the logical network diagram with the IP. So next we go to the network configuration. As usual, we can configure on any part first, but my preference is I would like to configure router first, because router is the heart of this design or this network actually. So let's configure the main router first. So just click the main router and go to the CLI is command line interface. So there is a prompt to enter initial no en or enable en that completely. As usual, we change the name. So we start with the configure or activate the G0G0 interface first. So from the global configuration mode, we enter the interface configuration mode by using the interface or int G0/0/0 and to assign the IP address for this interface like this. The subnet mask no shut to activate the IP and exit from the interface configuration mode. So exit again. Actually, we don't need to exit again. So now I just need to activate the another two interface for G001 and G002. So I enter G001 IP address. and the last interface is ntg00-2. This is for the guest user, for your information. Activate. Actually, we can use an command to go to user privilege mode, exit mode, and using the copy running config, startup config command to save the router configuration. So as we can see that the interface is activated and the indicator is changed from red to green here. So next we need to configure all the switches here. I think it will be a lot of effort we need to use, but never mind, let's start. To activate the interface, actually when we're using the switch, interface will be VLAN 1. Yes. And for information, when we configure the switch, it will have the default gateway. So for this, we need to assign the default gateway, which is the IP of router, the main router IP. Exit and go to the user privilege exit mode and save by using the copy running config startup command. Yeah, so then for switch user 1, next for switch user 2, and conf host name lookup to disable DNS lookup. Activate the interface. shard to activate the IP and exit to insert the IP default gateway. Next, for switch user 3, configure. So next, for the server switch. There are mistake here. So the IP address is 81 and the default gateway is become 81, right? Only minor mistake here, but I have covered this. Let's change this because we assign with the IP of 81. That no shard as usual. So this is the last switch for the switch guest user. Just config. Sign. Okay, so I've done configure all the switches. So now we go to the PC configuration here. But first, I think it's good to configure server first. So server SCP. We start with the SCP server first. SCP server first. For the usable host, actually it's okay when we don't use at T2 IP for the T2 because it's usable is flexible actually. It's just a disclaimer from me. So next, just configure the PC here. So we need to configure all of this PC. I think for the SOHO it's not quite a large amount of device compared to the campus network design, but I just can include that inside the project report that I have insert in the link on the description for this video. Do you all see the flow of the project report here? So this is the last PC inside the user subnet. And next we go to the guest network to configure the PC and the laptop inside this network. So this is the laptop configuration. It's same as the PC also. Nothing changed in here. There is no change between the PC and the laptop. But why I use laptop? Because it's a guest user, so logically they will have the laptop, right? Okay, after the network, I have done all the network configuration on the device. So next, let's go to the network testing and verification procedure. It is we have used ping command for this pipe. So let's go to the packet tracer. So now just ping. So now I will ping the user network into the guest network first. So open the command prompt from the PC on user network. So just type ping and insert the IP of the guest network. It will be request timeout for the first, and the other three will be have the time to leave. Right. Okay. And we ping again to get the perfect ping. Okay, alright. So next, I think for the server, FTP server, I just need to set up the service of the FTP. I just want to add the username Arif and the password is Arif also. Add. Just tick all of this and add. Alright. So just close and go to the PC. And I need to ping FTP server first. So I think it will same request timeout first, and they will be have the time to leave. Alright. Perfect ping. And the verification of the FTP server, I need to insert command FTP and insert the IP address of FTP server. So it asks the FTP server, asks the username, so I need to use Arif, and the password also Arif FTP directory and all of it. So it's success for the FTP service. So I think for the user is very good and it's complete. The ping is also doesn't have any error and there's no anomalies. So let's try to ping from guest user to the user. I just use the laptop to ping. The first will be request timeout and the other will have the time to leave. See, show request timeout. I don't know why. Let's try again. Let's try with the IP on. I don't know why, but I just will use the PC guest one. We cannot use web browser because we don't have web server of HTTP server. So just ping have time to leave. I don't know why laptop doesn't have this. So actually from this project for the part 1, the SOHO actually we need to implement the ACL access command list to block the guest network from get the reply from the user. So from this guest PC, as we can see, there is a reply that have time to leave. So right now, how how do we implement the ACL command? So let's go to implement the ACL command. So it will be implement on the main router. So let's go to the CLI first. Password. Right. So now just need to make it this interface become the group. So inside. So no shut. And next, let's go to the interface G001. Sorry, my mistake. And next for the switch. So this is the ACL command. So use the protocol of the UDP, TCP for the transport layer, and the ICMP ping. So let's try this first. amount. The last one is the bill of the material. So there are five bill of material for the router, switch, copper straight cable, through cable, Cisco GLCTE for the add-ons interface of the router, and crossover patch cord, which is the crossover cable. All from all of this bill of material is the intermediary device, cable, the end device will not include in the bill of material. So the total is in about 26,000 ringgit Malaysia. So I think that's all from me. Thank you for all for your cooperation, and that's all from me. Thank you. We'll see you later. Right.